Hello everyone. I'm Robot, and we'll be starting with the review club today. So today's review club focuses on a consensus change in the transaction version. So earlier, the transaction version of the in Bitcoin was stored in a signed integer, which was against the like the implementation in the consensus, where it is treated as a unsigned integer and it's always greater than zero, and it's never negative integer. So this PR was introduced to change that and bring it in consistency with the documentation. So this is the PR that we're going to review today. So we'll review the changes one by one. First is a really like trivial change. So since we are working with a version now which is unsigned, the n prefix is removed and it's now only version. It also adds to clarity that this is the transaction version and it's unsigned.
What did N mean before? I'm curious to know. Like you said, N was removed. Did N mean something before?
I guess earlier it was used. It is used for like variables which might or might not be signed. Like even though like log time and sequence are treated n sequence or n log time,
Yeah.
they are never like signed. They are treated as uint and are also uint in the code base. But since this n version was like treated as a signed integer,
Yeah.
and like this was treated as a signed integer and it is now changed to an unsigned integer, it might be the fact that it is used for like it is used for data types which might or might not be negative, like in some sense. Like versions cannot be negative. It is like common practice that versions are not kept negative. Log time and sequence, like, even the sequence cannot be negative also. Log time is not treated negative, but in some sense when you would like to change the log time, in a sense that when we treat blocks, we treat like there was a rule, I guess, for like since there is a difference in time zones uh, for the miners, like there is a lag between the miners in the network itself. So a difference of 6 blocks in like in the future, in the past, is maintained. So in that sense, even though log time is not like signed, uh, we can assume theoretically that it can be like signed, because lock time is used to lock the transactions for future. But if like to maintain consistency with the line of thought, it might be that n was added to represent that it might be signed.
I
So
see.
the thought might be, yeah. So uh, another change is in the mempool replacements in the policy documents. So n version is changed. The version is changed, is set to 3 now. In the standard Bitcoin transactions, the version is likely to be 1 or 2. It can also be 3 and 4, but like they specify, they are not like standard transactions. They are now standard transactions, but earlier in the code base where they were not. So the version 3 uh, signifies that the transaction supports RBF. So RBF is replacement by fee, uh, which is very crucial when uh, we would like to introduce transactions that we might think that they may or may not be accepted by the like accepted in the block because of low fees. And uh, and to like replace that transaction with another transaction, we introduce an sequence. So the if there are two similar transactions, the one with the lower sequence number is considered invalid in support of the transaction which has a higher n sequence number. So that transaction is now superseded the older transaction that might have been delayed due to various reasons. So the one is it the version 3 signifies that in the end sequence there is another uh, way of uh, relate we use relative log times to uh, introduce like restrictions in the output UTXO outputs that are being spent. So there are two ways that we can restrict the usability, or like usability might not be the correct word. We can say we put restrictions on the transaction to specify when that transaction can be used. So there are two ways. Either we change the sequence number with BIP68, which is relative time blocks, and there is this RBF method, replacement by fee. And in log times, we can also do that. In log times, we treat it as if the log time number is less than 500 million, we treat it as the block height, that number, and the transaction can be executed only after that number of blocks have been like mined. And if the number is greater than 500 million, we take into account that it is like the used in seconds of the seconds of time units that we might want the transaction to be implemented after. So these are the two. They are two. These two. The main difference between these two is that the lock time is used to put restrictions on the transaction itself, whereas the sequence is used to put restrictions on the outputs of the transaction. So this is the main difference between the two. It might be like explored more in the mastering Bitcoin cohort that is going on right now. I don't know the current update on where the cohort is, but it will be discussed in the future in great detail if it is not yet discussed. So yeah, that is about the theory part of it. And this line here is like more crucial change, depending on why there were issues of there might be some changes in consensus, like some changes. This change is introduced because there might be consensus failures in the future. So this a new version is like treated as a integer 64, and in the new version it is treated as a uint 32t. So the reason it is not uint 32t as in like as in the code which we will look after in this change, is that if you look at how the numbers are stored in these, you will see why this change has been introduced. So if we are like having integer 32 in place of this uint 64, we might have the issue of that total number of range that we might have. So the range we have for in 32 is minus to the power 31 to 2 to the power 31 minus 1. So this is the range we have when we have in 32t, and when we have unsigned integer of 32, the range is 0 to 2 to the power 32 minus 1. So in the documentation and in the implementation, this is used. And if we would have used this in place of uint 64t as in here, so you can like see that there are half of the numbers missing that are valid for uint 32t. So to include those numbers, it was stored as uint 64t. So this now updates to 63, and this also is updated to 63. So now the numbers are included which were left over. So this problem created issues before, and this is one of the main reasons the code was changed to like store the version in an unsigned integer. So the code changes majorly on that only. So here we are just changing the version to changing n version to version, and we are removing the casting done previously. So there are two types of casting. The one is explicit, which you can see here. We are casting the n version to an int, although it is a int 64t. Int t is another type. You can like see it in detail later. Yeah, so this is the example of explicit casting, and implicit casting is done automatically by the C compiler or C++ compiler, which you might be whichever you might be using. So this is just a document change. Yeah, so this one is the one I was talking about. This is the BIP 68 change. So BIP 68 needs a transaction version to be greater than equal to 2 for BIP 68. For RBF, it is version 3 or greater, and it is version 4 for snort signatures and in the transactions. And these are like there are only transactions that are included till version 4 in currently in the mainnet. And this is the change to remove casting.
Faisal has a question. You can go ahead, Faisal. Oh, was that accidental?
Yeah.
Oh no. You're on mute, Faisal. Access denied. Okay, cool. I guess you can go ahead. I'll tell you when he comes in.
Okay. Yeah, so the casting has been removed, which like turned it into a uint, and now there is only a uint check.
Oh,
Here,
let's see
I'm
the stat.
audible now, I think.
yeah,
I'm audible, right?
yeah, you are audible.
Yeah. So, Mike, can you go back to the code snippets? Can you scroll a little on top, further? All right. Yeah. So yeah, that's it. So it says a transaction also signals replaceability if its version field is set to 3. Uh, I think this is by default, is it? Transactions having version number even less than 3 are eligible for RBF using the sequence number. Now with V3 transactions, is it that RBF is default? You don't even have to use the sequence number.
Mm,
Because
like
even one transactions having version number 1 and 2, we can RBF them using the end sequence number. So why is 3 explicitly mentioned? Is it that for 1 and 2 RBF was not on by default? We had to indicate it using the end sequence number, and with 3 it's on by default.
yeah, I guess this is due to like backwards compatibility. If we are specifying this in the code base, I'm not sure to be honest, but yeah. So if we are running older softwares, which uh, some mining softwares might be using, uh, the earlier like requirement to have an RBF was to like signal version 3, but since you said that it now only requires the sequence number, this might be due to this now that the code base has been updated, and the new Bitcoin version support like does not have to signify that version 3. Yeah, but there is also like the change in the policy for version 3s. I read about the yeah.
Yeah, true. That's struct transactions. Version 3 basically it has a lot to do with pinning attacks and all, and cluster mempool and package relays. But I believe I like even like all of us when we get time, let's dig into it and see who gets there. But RBF 100% was sure was happening even before V3 transactions. Right, V3 transactions were incorporated recently this year itself. We've had RBF for quite some time, and we were RBFing transactions using the end sequence number. My hunch is that earlier it was off by default, and you had to switch it on using the end sequence number for version 1 and version 2. Now with version 3, they've made it on by default. So like every version 3 transaction is eligible for RBF, whether you signify it using the end sequence or no. That is my take, but like we can look into it later.
Yeah, definitely. Yeah, we can look into it. Like we can have a follow up of that in the GitHub issue, and
Right.
yeah, we'll see. Yeah, so going back into the code base, there are just version changes or the naming changes happening, and yeah, we are using the truck transactions here. It is only like naming changes as of now.
I think the majority of the files are just that the nomenclature changed from nVersion to version. Hardly 4 or 5 files have some actual code changes.
Yeah, even there, even from them, these are these casting changes that are introduced.
So Coding P is asking in the chat, can you please explain what is static casting?
Yeah, so like static casting is you would know about like difference between how we cast it during the compile time. So uh, we would compile these numbers uh, during the like these numbers when the difference is that of when are we like casting the numbers into different types. So if I'm correct, I believe static casting is static casting is when we are explicitly casting the number to a type that might lead to some loss in precision during the compile time. And if we don't specify the casting to be like static, the casting is done in the runtime code. So static casting just improves the latency because we are compiling it like we are also casting it during the compile time, and it takes a lot less time, while in the runtime casting would have to like update it every time, like, and cast it every time we are using it. So uh, that this is one of the like main agenda behind static casting. Like it does not make much of a difference, but when we are like building the code base and like then using it, these small changes of time savings like prove to be a lot beneficial. So i so i hope that's clear with that. Yeah, okay, go ahead. So these are just the nomenclature changes. There is a removal of casting. Mm, yeah, and one of the differences here is that uh, when we are like using uh, uints uh, in the code base and we specify this negative numbers, it generally overflows uh, because if we are like storing it in like the code base, we would like go back from the highest number to it. So minus one would be the highest number, which is this, the uint32t max number. And as we go ahead in the negative numbers, uh, then the actual absolute value goes down in the unsigned part. And this is one of the main this is one of the reasons that this code was changed to like have it in the uint itself, because overflow and underflow are in the integers is a big problem. And if that happens in the code base, that it might lead to big problems later, especially if it's in values or the output values, because then we'll be like spending some invalid amounts and that might break the system.
Yeah, this reminds me that in the blurb for the PR description, the PR author HO mentions that some problems were found in other clients, some consensus problems were found in other clients because of this inversion. Faisal,
That's BTCD, I believe.
it's BTCD. Oh,
Yes.
that's the goal.
And even they've made amendments recently, a few weeks ago or a month ago, whatever. So now there are no consensus classes.
Interesting. It was there in
Yeah, so,
Tech.
Yes.
Okay, nice.
yeah, no, going ahead.
Yes.
These are just naming changes. Yeah, so this part was using random number from the int part. Now it is totally converted to unsigned numbers. Signedness has been removed. So there is a test. This is for the minimum transaction number, which is 0, and this is to the power 32 minus 1.
Oh, could we look at the test again? Like, both of them should pass now, or like one of them fail?
Yeah, like I guess if we are talking about, there are some checks that the transactions should be in acceptable range. So 1, 2, 3, 4 are the acceptable range. If I'm correct. There is also like yeah.
No, I think standard is only 1, 2, 3, I believe.
Yeah, the standard. Yeah, the fourth one is the snore one is not included in the like code base yet, but because I believe there were some P2TR transactions.
And even the version number 3, Bitcoin Core will relay transactions that have version 3. But if you are using a Bitcoin Core wallet, your wallet will not create it. The wallet will only create transactions with versions 1 and 2, but it will relay, your node will relay 1, 2, and 3 as standard transactions.
Oh. Is it like we haven't added version 3 support in the wallet yet?
Yes, maybe the transition probably they're planning to do it slowly and gradually. So your wallet won't create weekly transactions, but your node will relay.
That makes sense. So I guess both of these then should fail because this is not falling in the range from 1 to 2. This is far greater and this is less than 1.
What was the check in the last line? Like, was it just decoding the transaction?
This one?
Not this one. The 0 and that 0 FFFFF. It is a bit more down, I think. Oh, no. Okay, can you scroll up?
Hey, we've got the text. If you can scroll down, sorry to interrupt, but there's a text that states what we just discussed. See in the last one. Yeah, see. Check wallet does not create transaction with N version 3 yet.
These transactions are started. Current is 2. This test can be removed if current version is changed and replaced with tests that handle B3 rules. Okay.
Yeah, that. Yeah, this like clearly is like according to what Faisal said. Yeah, then now like we can look into questions, I guess.
Sounds good.
Yeah. So first question is the difference between implicit and explicit casting. So I discussed it earlier when I was talking about the static casting. So we can look at the next question. So the code used to use uint32t instead of int32t instead of uint32t. What might be the possible issues that may have arisen during typecasting or like changing the values from sign to unsigned?
It's possible that there might have been, like for example, int32t, you mentioned that the range of int32t is from minus 2 power 31 to 2 power 31 minus 1, whereas for int32t, it's from 0 to 2 power 32 minus 1. So basically, if there was some transaction which was broadcasted, which had like a negative version number, if we make this change according to the current consensus rules, that transaction would be considered invalid. And that would be very bad.
Yeah, exactly. That is the reason this was changed. Yeah, I also discussed this one, why it is changed from 64T to in 32D. Yeah, this one was also discussed. So -1 causes the code to overflow and have the transaction with the maximum number. So that was also an issue. Basically, the two issues that were arising from having signed integers was that we were not including big range when we were using int32t instead of uint32t. So half the range was missing. And there was also the case of overflowing of the numbers when we would be using typecasting. So these two were the reasons that I assume are the major issues that led to this PR. And yeah, that is why this PR was introduced. So anything else somebody wants to ask about the PR or any comments about the PR?
Hey, nothing from my end. Thanks for hosting, Prabhat. If anybody else has anything to share or say, please go ahead. Nothing from my end specifically.
Nothing from my end either, but it is a very interesting consensus. It is interesting seeing a PR which could affect consensus rules. We haven't done that in our review clubs much. So yeah, thank you for hosting.
Yeah, thank you everybody. So I guess we can end the meet now.
Sounds good.
Right. Bye. Bye. Good night, everyone. Thank you.
Bye, Faisal.
Good night.
Bye,
Bye,
Coding
Strat.
Team.
Bye, Prabhat. And bye, Coding P. Bye. Bye, all of you. Good night.